Now come to the chapter laws of motion. Let's go to the introduction of laws of motion. Ancient scientists believed that suppose body is in motion, definitely there is a force. For example, body is in rest position. I want to body get the motion, definitely we have to force apply on this one. In such a case it become motion. Galileo is a famous scientist and he called as the father of modern physics. He did one of the famous experiment, Galileo inclined plane experiment. Galileo inclined plane experiment. See here what did he? Galileo take a smooth surface, that shape is U shape. This is the midpoint. Suppose ball is taken here at the height from the ground, so ball is released. So what is happening? Due to gravity, it's come to down. Up to this point, velocity is increased. Again, from this the point, its velocity is going decreases. Again, it reached the same height of other surface. The next one, it take another surface like this shape. See here, the slope is more. Now here slope is less. Again ball here is taken. See, from the ground it is at the height h. So this is ball is rolling on this surface. See here, again it raised up, but the ball goes to again here also at the same height. So here ball again rise up with the same height. Compare these displacements about this point. This displacement is less than this displacement. In third case, Galileo take. So this is curved path. This is the plane. Now ball is take here. Again it is also same height h from the ground. Now ball is rolling up to this point. So going, its velocity is increased from this point to this point. After reaching this the point, he observed that now ball is moving with uniform motion. So from this point, ball is moving with uniform motion. Now ball is moving along the horizontal line. No gravity force act on this one. Only gravity force is along this direction, that is vertical direction. Suppose any body is here, ground earth attracts the body along this direction. Force along this direction. See here, what is the force rotate? How much? 90 degrees. Suppose gravity force is Fg. fg cos 90. Cos 90 is 0, so this term is 0. So gravity force along the horizontal line is 0. Due to this is the smooth surface, friction force is also 0. So suppose we want to moving up, then a gravity force is objection here. Gravitation force acts on us. Suppose we want to moving forward, in such a case friction force act on us. These two forces are always exist on us. This body is coming down. While it is coming down, gravity force is act, but while it is moving along the horizontal, after this the point, your gravitation force is absent. This is a smooth surface. Friction force is also 0. So these two forces are not there. The body has no force, but body is moving with uniform motion. See here, at the starting of the class, we discussed one of the point. If suppose body is moving, definitely it has a force. But here, body is in uniform motion. Even there is no force. So from this experiment, we concluded that if suppose body has no force, then body is moving with uniform motion or in rest position. Body has no force, then status of the body is uniform motion or rest position. So after this experiment, we get this point additional. What is that? Body is moving with uniform motion. So ancient scientists believed that no force on the body, then the body is always in rest position. But now after the Galileo experiment, we concluded that additionally not only it is in the rest position or it become uniform motion. Next, this famous experiment was studied by the Newton. Additionally, he introduced one of the concepts, that is inertia. Inertia definition is, inertia is, it is inherent property of the body to change its state. So meaning of this one, discussed with some examples. Now I take two bodies with different masses. One is huge, other one is less. So this is huge mass, this is less mass. So both are in rest position. I want to disturb from this rest position. On both bodies, I give same forces. Initially, I start with the 0 force. Gradually, force is increased on both bodies. So force is gradually increased here. Initially, this body comes to motion. Later, it comes to the motion. It has more inherent property to change its rest position. Compare this one. We take another example. Suppose train is moving with uniform motion. Other one is cycle is moving. Now another one is cycle is moving with uniform motion. Suppose both are moving with the same velocity. I want to disturb both. Suppose we stand before the train and also the cycle, so the motion of the cycle is definitely disturbed, but the train is not disturbed because it has huge inherent property, that is indirectly it has huge mass, it is a less mass. So this uniform motion is not disturbed. But cycle is disturbed because it has less mass, so less inherent property. This inherent property is called inertia. Indirectly, inertia measures the mass. On the concept of inertia, Newton derived Newton's first law. Everybody continues in the state of rest or uniform motion until external force is applied on the body. That means up to force is applied on the body is always said to be rest or uniform motion. Here force should be applied more than inertia, then it is disturbed. This is actually rest or uniform motion is derived by the Galileo. Additionally, inertia concept is introduced by the Newton. Totally credit goes to the Newton. So this is the Newton first law statement. Next one, Newton's second law. We take some examples for inertia. Suppose bus is moving with uniform motion. You are standing in the bus without any support. Now suddenly brakes is applied to the bus. So in such a case, you fall down forward because due to inertia of motion. Look here, what is happening here? So you are standing on the floor. So floor legs are contact with the floor. There is a friction force between floor and legs friction. So due to friction force, you are standing on the floor. When apply the brakes, floor will be suddenly stopped. Due to that, your legs is suddenly stopped, but head is not stopped here because there is no contact with the bus. So this is in the motion, legs is become to the rest position. So what is happening? So head is moving forward. In such a case, you fall down forward. So this due to inertia of motion. Suppose bus suddenly start from rest. Same situation here also, you are standing on the floor. In such a case, see here, initially body is rest position, head and legs are in rest position. Suddenly bus is moving mean legs is moving, but head is rest position. So legs is moving forward, but head is on the same state. Immediately you fall down backward. So this is due to inertia of rest. Suppose we take a bottle. On the bottle I take one of the pad and a ball is placed on the exactly neck of the bottle. Now suddenly it is pulling. Suddenly pulling mean here friction is less. Friction become less, so that suppose this friction is less than the inertia, then body is said to be in still rest position. When it is removed, so support is removed, immediately it is fall down in the bottle. So what is the happening here? From this experiment, here inertia is more than the friction force. In the first law, if suppose force then body is in rest or uniform motion. Suppose force is applied on the body, what is happening? Newton observed so many cases. Finally, he decided force is depend upon mass and velocity of the body. Two bodies are moving whose masses are m and other one is 2m. Both have same velocities v and v. Suppose or hit the person, what is happening? In such a case, person is jumped from this point to this point, say something d. Here the person is jumped from this point to this, that is a 2d. So what is here? Mass is doubled, so force acting on the body is also doubled. It depends upon also velocity. Suppose two bodies moving with velocity is v, other one is 2v. Both bodies have same masses and hit the person in both cases. Suppose in case person is jumped from this point to this point, that is a d. Now in this case he jumped 2d distance. So what is happening here? Also proportional. So here force is depend upon velocity. So here force is depend upon mass and velocity. So these are two different physical quantities. One is mass, other one is velocity. But these two physical quantities together take as a one single physical quantity. So there are two mass velocity. If take as a single physical quantity, it is so much helpful to understand further concepts. So momentum is combined property of mass and velocity. So definition of momentum is product of mass and velocity. So momentum is denoted by P, mass is mv. So P is equal to mv. Let's a body mass m and moving with velocity u. So its momentum is mu. Now force is applied on the body, then velocity of the body is changed, velocity of the body is changed. Now it is moving with velocity v. So now the momentum is mv. Now the momentum is mv. See here, change in momentum, that is mv minus mu, is always directly proportional to f. He did so many experiments. Finally, he observed force is directly proportional to change in momentum. Change mean delta, P mean momentum. So Newton first observed that F is directly proportional to delta P. And also he observed the time interaction. Suppose we take the two different cases. One ball is coming down. You catch this ball with different cases. In the first case, see here, with your hand, the ball is suddenly stopped. Ball here suddenly stopped by your hand, but in other case, here also body is moving with same velocity. Now your hand, when the ball is touches the hand, simultaneously you pulling the hand downward. So here not suddenly stopped, it takes a time to stop the ball. See here, in which cases you get more pain, especially in this case more pain, but in this case less pain. So more pain means more force is here. Here less force is here. Look here, to stop it take more interval time, but here suddenly stopped. So here force is depend upon the time interval. If time interval is more, force is less. If time interval less, force is more. Okay, we'll take another example. Suppose you jumped from height on the rough floor. In other case, suppose at the same height, again you jumped on, suppose bed, on the bed. In which case you get more pain? Say on the rough floor you are stopped suddenly, but here takes the time to stop you. So here time interval more, force is less. Here time interval very less, almost all delta t tends to 0. In such a case, more force. So from these experiments, we say that F is inversely proportional to time interval. Now force is directly proportional to delta P. Force is, in second case, force is inversely proportional to delta T. From those two equations, finally we write as F directly proportional to delta P by delta T. If you take delta T is less tends to 0, small interval of the time, then delta become differentiation. See here, delta become differentiation, then F is directly proportional to dP by dt. See here, dP by dt is nothing but rate of change of momentum. Rate of change of momentum. So dp by dt, 1 by dt mean rate, dp mean change of momentum. So this is the Newton second law. So statement of the Newton second law is, so Newton's second law statement is, rate of change of momentum is directly proportional to force acts on the body in the direction of displacement. Derive the Newton's second law, that is the long answer. One time that was asked, so you should read this question. So you learn answer for this question. So first you write the statement of the Newton's second law. Rate of change of momentum is directly proportional to force acts on the body in the direction of displacement. So F is directly proportional to dp by dt. In the physics we have a rule, remove proportional and introduce the constant. Newton takes unit of the force, so that the bring the value of k is equal to 1. So here when k is equal to 1, F is equal to dp by dt. So F is equal to d by dt. What is the momentum? Mass into velocity, that is m into dv by dt. You know that dv by dt is nothing but acceleration. So F is equal to ma. So actually this is Newton's second law. F is equal to dp by dt. If suppose mass is constant, then F is equal to ma. So F is equal to dp by dt. Actually this is the Newton's second formula. In if suppose mass is constant, that is equal to ma. See here, in the long answer there is sub question is also there. Suppose body is moving with same speed in circular path, is there any force act on the body? That is a question. Now body is moving in circular path with same speed. So here magnitude is same, but velocity is a vector quantity. Vector mean it has magnitude and direction. If vector is constant, if only if magnitude and direction both are constants. Here when the body is moving in circular path, mean its direction is changed. When the direction is changed, vector is changed, so velocity is changed. So here velocity is changed. Change of velocity is nothing but that is the concept related to the acceleration. So here for circular path there is acceleration, because here direction is continuously changed. This type of acceleration is called centripetal acceleration. When there is acceleration, body should have mass. So mass and acceleration, definitely there is a force, because F is equal to what is the formula? ma. So acceleration is there, definitely there is a force. So there is centripetal force there. So here centripetal force is act on the body. So here force is exist on the body. So this is the answer.